G'day folks. Well, today I have something a little special for you. This is a little project I've been working on at my new job. Basically when I started here this area was just cabinets and junk. I got this extruder set up in a line and running with a bit of help from the guys here of course, but got everything painted up and installed, lined up, and I'm going to run through just how it works, provided you can hear me over the background of all the machinery. There's a fair bit going on, you'll hear compressors and things kick on, but I'll try and explain it as best as I can. Basically this is solid profile extrusion using polyethylene, low density polyethylene, and I'll sort of explain it from start to finish because it starts as granules, you'll see there. The little blue bits are master batch, the clear ones are natural material. So you got raw in, that goes up to the hopper loader, into the hopper, and down here. So being driven by this eddy current variable speed motor is a screw and barrel. This is the extruder itself from sort of here to here. So you've got a gear reduction, the screw, you can sort of see it moving there. It's only just moving. Yeah, a bit dark. Material gets conveyed down here, down the flights of the screw. These are heating bands. Material undergoes friction and thermal heating from the bands, turns into a liquid. The screw flights get narrower and narrower, compressing it down and pushing it out through the nozzle. The nozzle's about that big, it's about 6 mil, and that's the pressure at the die in PSI. So the die here is seeing about 800 PSI, fairly high, but it's just a positive displacement pump, and by the time it gets here the material is 220 degrees Celsius. This zone here is starting off at 210, 215, and then 220, and then the die is that, so 220. It hits the die, which is water cooled, which is coming up very slowly. And that's what you get. And very slowly. You can sort of see that there. Yeah, it moves with all the urgency of continental drift. That's the way I put it. Extrusion's not a fast game, but you get a really nice product when you take it slow. If you rush it, you end up with waves and lumps and all kinds of things. Looks like crap. Yeah, so the extruder itself, electric motor driven, variable speed. Motors sit about 150 RPM. The screw's probably doing about 8 or 9 RPM. And it's a very basic control cabinet. I've integrated the emergency cut-offs and the pump and everything into this, but that's about it. I just got to finish putting the indicator lights on. Water cooling is constant recirculation back to a water tank outside. There's a float switch here. When that gets too high, that pump over there kicks on. So now that pump's on, that'll drain this to the point where that float switch turns off. So that float switch has a tip point. That overflowed the first weekend we ran, or weeknight we ran this on its own, because this can run 24/7. The pump cavitated because a check valve leaked and there was water from one side of the factory to the other. That was not a fun morning. But I've got brand new check valves in there instead of trying to trust a used one. Yeah, that happens. Every now and then you get a bit of a flood. So yeah, this compartment's dry, it's just an overflow. And the water's probably 18 degrees. There's 2 jets in the bottom and one on the top. So it's just knocking the heat down as soon as it's coming out of that die there, because the die starts right there. So you've got nozzle, die, and then cooling. This is auto cut off. If that stops for more than 10 seconds, a trigger in here shuts off everything, including the haul off, the motor and the heaters. It just kills it. So that's in case something goes wrong or it runs out of material, the material stops moving, bang, shut down. And that's just their counter for cut to length. So this is the haul off. This just maintains a steady speed. It's moving at 50 equals 46 millimeters per minute. This is off. This is a little bit off, but it's doing 46 millimeters per minute, and the product's not coming out swollen. It's not coming out sucked in or collapsed. It's coming out beautifully smooth. It has recently had a die clean because it made a bit of a mess before. But yeah, these little belts are just moving, only just. So yeah, that's called a hauler or haul off. And that's just an automated saw that's triggered when the counter gets to a certain point. It goes to X amount, whatever that count, whatever the set count is. Oh, set count's 275. So when it reaches 275, it'll start a process which clamps and then cuts the material and drops it on the floor like that. And as you can see, the one that's all wavy is before the die was cleaned. It was having all kinds of problems. Yeah, that's what can go wrong. But that's what it's supposed to look like. Can't tell you what it is for. I was told not to tell you what it's for, but I can certainly show you, because it's just really just a flat profile moulding. So yeah, you got from start, extruder, electric motor power conveying material, heat, liquid material forming inside a die at a specific rate, a controlled steady rate, and then cooling and output measuring and cutting. Really straightforward. So yeah, this is what I've been working on for a while, and currently doing other little things and cleaning up their tool room and everything, which is cool. Yeah, it's good work. So yeah, we're going to put one of them, and the amber which goes to the hopper loader to tell me when it's out of material. Because if that cycles for too long and doesn't trip its little switch, it'll throw up an amber saying, hey, I'm out of material, fill me back up. Controls are really straightforward. Old school contactors, no computers or anything. All I've done is tie into this, which is your safety cutout. That's what the encoder reads. It's on, I think, 9-second cutout. Should be 10. I've added a couple of power outlets, one for the pump, which is always on, and one for the haul off, which is switched by the auto. If something goes wrong, that gets cut, along with the motor, the heaters, everything. So yeah, it's just a matter of integrating everything in. It's not the tidiest of cabinets, but I made it a bit tidier. Yeah, a bit dark. There we go. This machine would be 1980s tech. There we go. Loading. And now that'll drop into the hopper and stay that way. If it runs out and that flap keeps closing, it'll sound it won't sound an alarm. The alarm's been replaced with an orange light. The alarms get annoying, so they're all been removed and we just have orange lights. You don't want warning beacons going off on when you've got, I don't know, 2, 4, 6, 8. There's about 10 machines now. So yeah, eventually I'll probably replace all these with solid state relays. Better than the noisy old contactors. I think all the new ones generally run SSRs. They've all been converted over, so that's one of the things to do. I've got to finish putting the lights on it, tie them into the related circuits. You've got green for auto on, red for I'm in trouble, and amber for material out. And yeah, heating bands. Each heating band's almost 1,000 watts, I think. And you might ask why there's fans on there. If the temperature gets too high, like if you're running a fast screw, a fast process, and the temperature gets too high from friction, the heaters won't be running, but you'll use fans to knock the temperature down and stabilise it again. Otherwise the temperature gets too high and you start burning your material. So it can work either way. It'll either need heat or reject heat. And that gadget down there is the pressure transducer that's giving us that reading right from there. Transducer reads off that. So there you go. It's not a fast process, it's not an exciting process, but it's necessary to how we live, because extrusion makes a lot of things. And that's what happens when you purge it out. It was purged without the dye on it. Yeah, extrusion makes a lot of things, from a plumbing pipe to wear strips, PE sheet, plastic sheet, acetyl, nylon, Teflon, you name it. Just gotta keep waving the back of the motor. The motor's not breathing. These are an interesting drive too. The motor still does 1440 RPM all day long, but it's got sort of a magnetic slip coupling called an eddy current coupling. I'll have to get one of these that doesn't work and tear it apart for you. They're quite interesting. Yeah, so that'll be next. Probably one of my next autopsies. I think there's a short-circuited one out in the new factory where we're going to have all the auction surplus. I'll see if I can score that for scrap metal and take it apart. Anyway, I think that's about it. I'm pretty sure I've missed something, but that's sort of extrusion in a nutshell. It's a very slow process, but it works. It's been around for a very long time. I've always thought I'd love to mount one about this size on a massive factory-sized gantry, multi-axis gantry, and use it as a giant 3D printer. They'd stick it to all the little kiddies with their maker bots. I'm out of blue. Just getting refills now. Yeah, this was a project from the last couple of days, putting a water jacket on this new die after turning it to size. It was just a round flat billet that had been wire EDM'd, and turned that, fit the jacket, silicon rubber O-ring, and got it ready for a trial, which is exactly what's happening now. I just can't show you or give you any information on what the product is because it's brand new. Right now all you see is something flat coming out. That's all that matters. But yeah, this is a fairly new Chinese machine, fancy new controls and everything. It's definitely a step up from the 1980s tech that we're working with, but yeah, it's all a little more up to date. But that's about all I can show you on this one. That's been a couple of days worth of tool making work that I've done. And so far, a few hiccups on the first trial, now we're on the second one. See how we go. That's the brand of it. Basic import machine with a half-decent HMI. Last of all, this is a machine that runs quite a while. It's running a mixture of fresh and regrind with a bit of talcum powder mixed in to keep the static down. It's a modern Johns 3-phase variable speed motor. It's a SL45, I think it's 45mm bore, a bit bigger than the 32 behind me. But same principle. You got the screw. You can sort of see in there. It's only doing, I think, 18 RPM. Not very fast. Big ABB 10 horsepower motor on it, something like that. It's about the same size as the one I pulled out of the old Battenfeld overmoulder. Can't show you that because it's got a lockout on the door. Same with the Chinese one, I can't show you till it's off. And right now these are running. There's the nozzle and die head. I can show you what this is. This is solid rod. If it's a non-proprietary shape or nothing special, I'm allowed to show you, but the new die that I've been working on is pretty special, so I can't do anything about that. Same principle for measuring. You've got an encoder for the auto and a counter for the length. A weight system to make sure it doesn't come out too fast and either pull in or blow out. It's all speed related, but yeah, that's a solid poly rod. This is machining rod. And it just goes all the way down to an automatic cut-off. Pretty easy. Same system, pump, tank, float switch. Yeah, it's not rocket science, but it's still interesting stuff. I've never really worked in extrusion up until now, and yeah, it's good. Mind you, it's not my job to set up and run them, it's my job to fix things and that sort of thing. I'm the maintenance fitter. I'm the guy who fixes stuff when it's busted. Yeah, it's telling me it is out of material. Because there's the hopper loader pickup. I'm just refilling it now. So that's what it's doing. It's asking for more material, but that won't run out anytime soon. It's still mostly full. And there are all your zones. Zone 3 being the back, Zone 2, Zone 1, die 1 and head clamp. So the head clamp has its own heating band, the die has its own heating band, and then you got one, I think that's 1, 2 and then 3, yeah, it's back to front. This is a straight reduction gearbox, there's no belt drive, this is direct drive. Little oil indicator. So oil pump's doing motor RPM, and you got reduction, and the screw, which is doing about 18 RPM. Just moseying along. And it's an externally fan-cooled motor. It's got an electric fan on the back of it, so when it's running at really slow RPM, it gets adequate cooling, but it's only lukewarm. It's barely under any stress at all. Pick up back in. And last off, this is basically going to be my lair for whenever I've got a project to do. I have been going through and having a massive clean-up. It was a bit of a mess, but yeah, filling the rubbish bins in the scrap bin bit by bit. Got plenty of stock, that sort of thing. A couple of big lathes. CNCs aren't my department. There's a couple of Daewoo Pumas, CNC lathes, and a Daewoo VMC. I'll get to play with the VMC soon though. But yeah, I've got a nice big lathe. This one needs some attention. The clutch doesn't fully disengage until you sort of hold it in the sweet spot, and then it stops the spindle. So I basically stop the motor and everything at the same time. So I've got to get in there and fix that. It's a bit of a safety issue. Because right now, if I start it now, it'll start coasting backwards. I think it will. Yeah. So it'll just sit there and coast. You sort of got to find that little sweet spot. Yeah, got to fix that. But overall, not a bad machine. That needs some love and care. Need a spring for that. I've got to get on eBay and have a look. If I can't find one, if someone wants to let me know where I might be able to find the spring mechanism, because as soon as you release the clamp, the spindle just likes to go thunk and drop down. Yeah, like that. It's just trying to drop on me. It's a pain in the ass. So I've got to fix that. This one's pretty good, but it's got a bit of a death rattle in the gearbox. Again, not too happy about that. Just this knocking noise. Oh, that's not good. I'm thinking input shaft bearing. It's got a nasty death knock to it. So that needs fixing. But at least this one's safe when it's not in gear. Good power feed. That all works. It's pretty accurate. Again, it's just what's going on in there worries me sometimes, especially when it's warm. It's not so bad now, but when it's hot, yeah, that glass is low. I think that's part of the problem. Yeah, anyway. So that is about all for now. Thanks for watching. Here's what the screws look like. I found a couple of these today. There's 3 matching ones and 1 different one. And that's the little drive from the gearbox. But basically the material comes in here and gets conveyed down, generating heat and friction. And you can see the flights get shallower too. So it's compressing it more, higher pressure, and then comes out past the tip to the die. It's pretty straightforward. You use friction or shear and outside heating through heating bands, or if you run it fast enough you make that much friction that you have to get rid of that heat using the cooling fans. The heaters don't do anything. So yeah, there's an example of some screws.